Hello Algebra 2. I'm sorry I'm not at school today, but hopefully this video serves as a decent substitute. This is my first time doing what I'm doing exactly. I know the video quality isn't that good, but let's try it out and let's rock and roll. Today we're reviewing 5.1 and 5.2 vertex form and standard form for quadratic functions. So we only have two problems to do before you can work on your homework for the rest of the class period. And the first one that we're going to start with is vertex form. Remember, this is section 5.2, and here's our equation. So we have y equals the quantity of x plus 1 squared minus 2. All right, remember the first thing that we have to do if it's in vertex form or standard form is find the axis of symmetry. So to find the axis of symmetry in vertex form, it's a little bit easier than standard form. So if you remember from the previous 2 days, what we do is set these parentheses, what's inside those parentheses equal to 0, and we solve for x. So we'll set x plus 1 equal to 0, subtract 1 on both sides, and we get x equals negative 1. So that's our axis of symmetry. Alright, now the vertex has the same x value because the vertex is on that axis of symmetry. So the x value of the vertex is negative 1, and all we have to do in vertex form is identify what we're adding or subtracting in that equation. Of course, we could plug in negative 1 into the equation to figure out the y value, but we would just get negative 2. That's the one handy thing about vertex form. It gives us the x value and the y value right away in the equation. Alright, now the next thing is to look at the direction of opening. Now the direction of opening is dependent on a, and a is that coefficient in front of x. It's what we're multiplying by x. Now you can't see it, but we're multiplying by 1. So since a equals 1, which is a positive integer, this thing is going to open up. So the direction of opening is going to be up, which means that it's going to be an upward facing u when we draw this parabola, which means there's going to be a minimum value. So when we get to min or max coordinates, there's going to be a min, and that min value is going to be negative 2. So we can just write minimum of negative 2. Boom. Now, once again, like we did the other 2 days, we're going to hold those x-intercepts for later once we graph the function. Now, in order to graph the function, we're going to make a table. So on the left side, we're going to make a table of x and y values. And as you guys know, we're going to put that vertex right in the middle. Okay, so once we put it right in the middle, we're going to choose 2x values lesser, 2x values greater, and now we can plug those into the function. So I'm going to show my work up here, and I'm going to plug negative 3, that's the first one, now I'm going to plug into the function. Alright, so starting with the negative 3, negative 3 plus 1 will give us negative 2. We'll take negative 2 squared to get 4, and then 4 minus 2 is 2. So our first point, negative 3, comma 2. Then when we take negative 2, negative 2 plus 1 is going to be negative 1. Negative 1 squared is 1. And then 1 minus 2 will give us a negative 1. Now we'll plug in 0 and 1 as well. So 0 plus 1 is 1. 1 squared is 1. 1 minus 2 also gives us negative 1 like before. Then 1 plus 1 is 2. 2 squared is 4. 4 minus 2, also 2. Okay, so if we look at our table, we see some symmetry, just like we should see in our graph. Alright, now we can plot those points. Alright, so I'm going to start by plotting the vertex, negative 1, negative 2. Then negative 2, negative 1. Negative 3, comma 2. 0, negative 1. And 1, comma 2. Now, like I told you guys yesterday, I was going to talk about the pattern in which we could find some of these points on a graph a little bit easier. So with a quadratic, there isn't a constant rate of change, but our change does go up by the same amounts every single time dependent upon what a is. So if a equals 1, that next y value from the vertex is going to go up 1 unit. Okay, then from there, we could just add 2, and then it's going to go up 3 units. And then if we were trying to find the next value, so we could plot a good graph, we'd go up 5 units. 1, 2, 3, 4, 5, right here on both sides. So that'll allow us, if we can figure out this pattern, that'll allow us to graph this function a little bit easier so that we can get a pretty nice graph. Now, of course, I'm not the best artist, so there you go. That's about the best that you're going to get. Now, if a were anything different, so for example, if a was 2, all we would have to do is multiply each one of these changes by 2. So from our vertex, that next point would go up 2 units. Then from there, 2 times 3 is 6, so the next one would go up 6 units. Then from there, 2 times 5 is 10, so the next point would go up 10 units. So that's how we could use this pattern a little bit easier to figure out those next y values. If it were a negative, like if a equals -1, like in the next example, if we multiply this by -1, that next value would go down 1. From there, it would go down 3. Then from there, it would go down 5. Okay, so take this as you will. If you want to use the pattern, you can. If not, you can continue to use the table. All right, let's look at the next problem. All right, so the next problem in standard form is y equals the opposite of x squared minus 4x minus 2. All right, so in standard form, we have to use the opposite of b over 2a. Now in this case, once again, like I've told you guys before, it would be best to identify a, b, and c in the equation. All right, so a is -1, b is -4, c is -2. Okay, from here, we figure out the opposite of b over 2a. The opposite of b is 4. 2 times a is going to be -2. So our axis of symmetry is going to be x equals -2. Now once again, the x value of the vertex is going to be -2, and what we have to do is plug that back in to figure out what the y value is. So if we plug that back in our equation, we're going to do it -2 squared, which is 4. Now this negative sign is going to come down, so we have -4. All right, -4 times -2 is +8. Now we have -4 plus 8, which is 4. 4 minus 2 gives us 2. So the y value of the vertex is going to be 2. All right, once again, the direction of opening is dependent on a. A is -1, so this thing is going to open down. And if it is opening down, it's going to be an upside down U, which means it's going to have a maximum. And the maximum coordinate is going to be 2. So we can say it has a max of 2. Now once again, just like before, the x-intercepts, we'll wait till later. So in creating our table, we put the vertex in the middle, choose 2 lesser values, 2 greater values, and now we could use that pattern that I was talking about. So when a equals 1, here's the changes. From the vertex, we would add 1 to get to that next value, add 3, then add 5. But in this case, a is -1. So since a is -1, the first thing that we're going to do is go down 1. And we'd get 1. Then we'd go down 3. And we'd get -2. And then to form a good graph so that we can get a nice curve, we'd go down 5 to get 2 more points. So let's graph these points. So -2, comma 2, -3, comma 1, negative 4, negative 2, negative 1, 1, and 0, negative 2. Like I was saying before with that pattern, we could figure out what this next value is going to be. We just went down 3. Now we're going to go down 5 to get those next values. So down 5. And these would be the next points. Alright, that means we could get a nice curve here and draw a pretty good graph. Now with this example, if we look at the x-coordinates, or the x-intercepts, we can see that it's crossing between negative 4 and negative 3. So where we see the x-intercepts, we can write between negative 4 and negative 3. And for the other x-intercept, we can see it's crossing from negative 1 to 0. So we would write between negative 1 and 0. Alright, if you have any questions, please email me. With the rest of the time in the class, please work on the 5.1 to 5.2 review worksheet. Thank you, and I hope you guys have a good weekend.